Hello. Good morning, good afternoon. Greetings from San Francisco. This is Umesh Horegata. I am the Chief Technology Officer at New Sigma U Square Analytics Lab. I also have Mr. Umesha Nayak today, who is the co-author of my book, Business Analytics Using R, and also CEO of New Sigma U Square Analytics Lab, where we provide AI solutions and also we mentor, guide, and conduct workshops on AI, machine learning, deep learning, etc. So today we are going to talk about an important aspect of data science, that is the data. And in particular, we are going to talk about data integration and data normalization. So we are going to discuss the challenges that we face when we integrate data from different sources and why data normalization is very important to build machine learning models. And also we are going to discuss about how machine learning can be used to solve some of the challenges related to the data integration. It will be a very interesting session. I request all of you to ask questions at the end of the session so that we can answer all your clarification, we answer all your questions and clarify if you have any further doubts. So first things first, this is the outline. We are going to talk about what are the challenges in AI and machine learning, and then what are the data integration, what is data integration, and then we talk about some of the techniques that are used to solve some of the challenges related to the data integration, and then we talk about data normalization, and then what are the techniques that are there in data normalization, and then finally we take Q&A. So in each of these sections, we are going to talk about the case study, and we talk about our research, and also we talk about our findings. So if you have any questions, again, please post in the question to the audience section, and then we will definitely answer towards the end. So what are the challenges? Why data integration and data normalization is necessary? So we have today abundance of data so that are there in the organization. It has been collected over a period of time through various applications, various different databases that may exist in different places, and maybe data may not be in one place to understand how your data can solve some of the business problems. Okay. So how the data can be relevant to solve your business need. So data may not be in a proper shape. It may not be in a place, in one single place, and where you can solve some of the business problems and understand the hidden patterns that exist in the data. So as a whole big picture, so data may not be there in one place, and you would like to bring all this data into one place and then try to understand what kind of patterns that you see in order to solve some of the business challenges that you have. And also to do this, you also need some of the tools, and then you also need resources. So you may need a SQL engineer, you may need a data engineer or data plumber, and also you may need a data scientist, and then you also would require various tools and technologies to solve this data integration problem. And that is exactly what we are going to discuss in today's topic. So what are the business needs? As I said, data may not be in one specific place. So in order for the business to understand, to discover some of the hidden patterns in the data, so data has to be in proper shape, proper structure, and to discover your business knowledge which is embedded on hidden in the data. And also business wants to improve how corporate customers as well as the corporate people access your data, how accurately you can access the data, and then how can we improve the data accuracy in your database. Of course, to discovering your hidden facts in the data and then speeding up some of the decision making in the corporate. So instead of going to different database and trying to find out various information, so if you can bring all these different data into one place and then you just go and discover patterns in one single data source, so that will give, that will speed up your decision in terms of any business problems that you would like to solve. And you have data in hand at any given time, and you will be able to make a better decision, again, informed decision. So, of course, the whole, automating the whole discovery and exploration, all these things is an important part of data integration, and that is today's need from the business. And that is why you need data integration. So let us, try to understand a little bit theory, what exactly we mean by data integration. So what is data integration? So in a simple term, data integration is bringing data into one place. So as I said, data may be residing in different sources, different places. You have acquired various organizations or various companies over a period of time, and each company may be using a different database. So different applications may be there, and all these things are distributed, and they are all sitting at various places. As a chief executive officer, if you want to understand what kind of patterns that you would like to solve using the data, or you would like to see the patterns in the data, so then you have to pull various reports from various databases, various sources. So instead, if you can bring all this data into one place, and then how can we connect different data elements that exist within the data? So that is the goal of your, the data integration, and it will provide a unified view of the data. That is what is basically the purpose of data integration. So why do we need, or why business needs providing a unique primary key for your data retrieval, and then faster data retrieval, providing one single view, and of course removing any data duplicates that can exist in the data while you are integrating different data from different sources. There is a high possibility of data duplicates that could exist, and to remove the data duplicates. And of course, the goal is to retain only the useful data to make sense out of the data and to solve the business problem at a much better and much faster way. So that is what is the data integration is all about. And while you are integrating data, so data can be of any type. It can be structured, it can be unstructured, it can be in various different formats, it can be of different size. So it can be, as I said, from multiple sources you are trying to bring the data together. So you will have different type of database, different type of formats. So one of the challenges, bring all these different data and then try to put it in one single format, maybe. So that would help to make the business decision faster, and also to consolidate all this data in one place and addressing all the challenges that I mentioned earlier. Okay. So similar records. Whenever you are integrating data from different sources, you will have similar records that could exist in the data. So when I say similar records, so there may be similar features or columns that could exist from different database. It could be very similar, and since you are having hundreds and thousands of features and hundreds and thousands of columns, some of them may be similar. So why do you want to keep all the similar features in the database? So how can we identify that they are all similar? And of course, you have millions of records, and some of them may be similar, some may be exactly same, it may be a duplicate. So this is what we refer as similar records, and this is the challenge that you face whenever you integrate different data sources and whenever you do data integration. So this is an example of similar records. Throughout our discussion in this session, we are going to talk about similar records and how can we address this particular problem. How do we address this using some of the machine learning tools and techniques. So that is what we are going to focus more and more on the similar records, because this is a key challenge we face while we are integrating the data. So if you look at the one highlighted in yellow, the first row and the fourth row, they're almost similar. However, the ID has got only one variation. Instead of 1111, it has got 1112. However, can we say these two are same because all the other things are exactly the same, except the phone number is also kind of different. So are these two people are the same? They just change their phone number? How do we know that these two records are similar? And how similar, if at all you want to consider these two are similar records? Similarly, if you look at the third column and the fifth column, fifth row, third and fifth row, if you look at it, they are exactly the same, right? So the name is exactly the same, the ID is also exactly the same, address is different, phone number is also different. Now, can we say these two records are same? So just maybe it is a typographical error, or maybe just somebody entered it wrongly. Is it possible because they have the same ID? So how do we say that these are all the same records? So when you integrate data, so this is what exactly could happen, and how can we identify these similar records? So what are the techniques we can use to do this? So that is just to give you a statistics of from the Oracle database vendor, in 1 hour, about 240 businesses will change the address, and 150 business telephone numbers will change or disconnected. About 2,500 individuals will change the address, and about 475 individuals get married. So that means the status of all these people can change, and you have to either keep multiple records of the same individuals, or so you can say, all these things are all same, and then you take an action so that there won't be any redundant data that exists, which could hamper your decision making and also your analytics. Okay. So as I said, your data integration solution should provide an effective access, speed, and connectivity for efficiently processing your data. And it should be able to scale. So because today you have 100 sources, tomorrow you may have maybe another 10 sources you are going to add, and you should be able to also on demand, you should be able to scale up or scale down resources. Right. So also if your data integration solution can provide data as a service, it can deliver data as a service, it can be cloud-based, it can be integration technology to anyone who needs them at any given time, and it should also support batch and real-time processing. So any of this, data integration solution should provide all these things. At least that should help the business to move forward and make better informed decisions. So again, when you integrate, you should also consider integrating with the big data platform. So that will help in providing huge storage capacity, and it will also help in parallel processing, and of course that will speed up accessing data at any given time, integrating aspects of processing, real-time offline processing, online real-time processing. All these things will definitely help, and then you should be considering having a big data platform, so that will provide a unified view, and then that will further provide you a platform to do your any of the big data analytics. So definitely we should consider going for big data platform. Let us quickly look at some of the techniques that we use in solving some of the challenges that we have in data integration. So as I said, whenever you integrate data from multiple sources, so you have similar records, that is, you have same records that could exist or repeat, and also you have multiple features or columns which could be very similar, which could be same. So, and also you have a limited knowledge of the features. So how can we solve this problem? So before I go to answering the question, I would like the audience to take this quiz, and I would like to hear from the audience, what kind of data integration problem that we just mentioned about it, and I want to see if you have come across any such kind of problem in your organization. Is it a duplicate field, duplicate records, or inconsistency among various records, or critical data missing or incorrect? I just would like to hear from the audience. So as audience vote their answers, so I would like to vote and talk about what kind of solutions that we have in identifying similar records, whether there is any machine learning techniques can we adopt, and I would like to talk about our research work and what are the outcomes that we have seen in our work. So if you look at these two birds, which are of same probably species, so they are very similar. Both are parrots. We try to identify. Okay, the beaks are same. The wings. They have the legs. The shape is almost same. Only the color there is a difference, but other characteristics are same. And we try to find out what are these characteristics. Is there any way we can find out how much similar these two figures? In this example, I have taken as an image, or if you want to take two similar text strings or two numbers, we can try to find out what are these, how much similar are these two records, right? And then once we identify these things and see whether we can transform these pair of records that we have found out the similarity measures into clusters of duplicate records, so that we can further say, hey, these records, 5 records are duplicates, and these 3 records are not duplicates, or similar records. Okay, so that is the technique that we could use in order to find the similar record. So as a first step, you have to find out the measure between the pairs, so how similar they are, and there are various measures that are available. You can use either an Hamming distance or other similarity measures such as Jaccard Similarity, cosine similarity, mean squared error, normalized mean squared error, structured similarity index, weighted similarity index, or multiple weighted similarity index. So the structured similarity, the last 3 or 4 that I mentioned, they are very much used for identifying how similar the two images are. Right? So the example I showed you previously, so those two images, how similar are they? So if I find a structural similarity index, so that will give me, how similar these two images are. Similarly, Jaccard similarity, cosine similarity are used to find out how similar two text strings are, for example. Okay. So Jaccard similarity, as I said, so if you have two sets of strings, S1 and S2, two sets of words, and the intersection of this will give you the size of, will give you the Jaccard similarity measure. For example, if you take these two sets, S1 and S2, and you have n number of words, let us say, so then 4 words, they kind of intersect between the two sets, and then 4 out of 11 would be your Jaccard similarity. That's an example. And then cosine similarity, again, these are heavily used in your information retrieval and trying to identify how similar two documents are. But we are just taking this and see how we can implement this particular feature in identifying some of the similar records that could exist in the database, right? So, but however, this itself we cannot say this is a machine learning. So it will just give you a similarity matrix or similarity number, how similar these two are. So cosine similarity, basically, if you consider x and y are two vectors, the words, if you want to say, and how documents of words. X has got a document X and Y, which has got so many number of words, and how aligned all these words are, how similar the words are. So the X and Y, for example, if they are almost, they are aligned, then the 0 degree, the cosine of 0 is 1. That is, they are highly aligned, highly correlated. Similarly, if there are no common words between two sets of documents, X and Y, so then it's a 90 degree. They are orthogonal to each other, and then cosine of X and Y is 0. So that is what is the measure basically, which will give you how similar these words are. So once we do this similarity measures, we have a bunch of numbers that will give you the similarity measure. And once we have these similarity measures, so then we try to group them into clusters and see, how many clusters we can form and how can we further classify or group these similar records or duplicate records. So, for example, let us say that you have 4 or 5 records A, B, C, D, and E, and then you try to calculate the similarity measures of A and B, B and C, C and E, and C and D. And it so happens, there may be 3 of them may be similar, and maybe 2 of them may not be similar, and you can group them separately based on similarity measure. Right? So, so this will give us, further we take this probability, the P1, P2 similarity measure, and then try to make it as a cluster, and then try to see how can we further group. In this case, P1 and P2, this is just an example, we can group them together, and P3 and P4, we can group them together. So what does that mean is, A, B, C may be one group, and C, D, D and E may be another group, or maybe C, D, and E may be another group. They are similar. So that's what we do. First we take the similarity measure, then we take these pairwise similarity measures, and then we try to group them together and further say, hey, these are the records which are similar, and these are the records so that are not similar. So the clustering is one of the unsupervised machine learning. So we could adopt this particular concept here in order to group or identify these similar records. So again, this is one of the machine learning techniques. So we are trying to adopt that in order to solve some of the data integration problems that we have. So while we are measuring the similarity, you have a character matching, that is you can measure the whole field, or you can take just the first 2 words, first 3 words, or if you want to consider first 3 characters or first 5 characters. So these are all some of the decisions that you take depending on what kind of measure or what kind of record that you are trying to find the similarity. For example, in this case, I have just shown as an address field. So if you want to take just the first 2 characters and you want to see how similar or how many records which have got the 3071 East, for example, right? So you can try all these different options and to see how you are able to identify the similar records or how much accurately you are able to do it using these techniques. Okay. Another concept that you may have heard is called data profiling. Most of the big database companies talk about these data profiling. There are many tools provided by Oracle or IBM and other database solution vendors. That is not necessarily, the data integration. So data profiling is more to do with address standardization, name standardization, and try to identify some of the metadata information or try to find out statistics related to the data. So, but that is not exactly data integration, but once you integrate the data, you can still use some of these tools to do your address standardization and name standardization. So I will not talk about what is address standardization, the name standardization, which is not the scope of this particular session. Once we have identified, or the first step is to identify, okay, these are the similar records. So now, one more thing that we could try to do is, can we optimize the number of parameters or number of features? So we would have, there may be 10 features, or maybe there is 100 features. We would have considered, or there may be all similar. Can we use any of these machine learning techniques to see or to remove some of the important features, or some of the just to keep the important features and remove the features that are not important? So we could adopt logistic regression or any of the linear discriminant analysis, and once we have identified what are the similar records, so we can label them, these are the similar records and these are the distinct records, and then we try to build a model to see what are the probability weights of these features, and then try to eliminate the features that are not important, and thus keep only the features that are relevant or that are important. So and also you could use this model to predict any new data going forward, any new source that you want to integrate, and which it could identify whether it is similar or it is distinct based on already trained model that you have. So you can also use deep learning or any other techniques to do this particular to solve this particular problem. And we have tried the various techniques which I will just discuss in a few minutes. While we are talking about the other methods, I would like to hear, what other machine learning techniques we could adopt. Can we use linear discriminant analysis or neural networks or support vector machines or PCA? So I would like to get an vote from the audience. And while you are answering these questions, I just would like to talk about some of the research and some of the research work that we did and what we got. So this is an example, case example. Basically, finding out similar records, that is the objective of this particular case, and we just we use similarity measures as I said, and we also use neural network to identify or predict any new source that you want to integrate, and this is just an example of the data that we have used. And we have taken basically the ID, the name, address, and other parameters, and see whether we can identify any similar records. So using similarity measures, first we try to group them, and we try to use the clustering technique to identify, okay, to label these are the duplicate record or similar records, and these are not similar records, and then we fed it into our neural network and to build a model and also to predict. And further, we provided a new source, a new test data, and see how well it can predict whether this already exists or it's a new record. And we are almost able to achieve about 75% accuracy, and this is just a the graph that what we have, the loss and the accuracy graph for both training and test data. So that is what is the first the results of our data integration, the first session that we have covered. And now I will hand it over to Umesh Nayak, who is going to talk about data normalization and what exactly the data normalization, what are the importance of data normalization, and what kind of techniques that we could use. Also, he will talk about some of the tools. Over to you, Umesh.
Thanks, Umesh, and good morning, good afternoon, everybody. Thanks for joining this session, and I will be talking about data normalization techniques. This is very important. Basically, the input to any of the model generation activity need to be accurate, correct, if we have to get reliable models being built, and that is why data normalization techniques are very, very important. And so why we are highlighting this is that we have seen in practice, in the zeal of solving the problem or going ahead with the model building, people forget to normalize the data and get a wrong model. And many times we have seen that people do not realize that they had to do the normalization. That is why we are talking about this in particular. What and why of data transformation? What? In the context of data science, data transformation is the process of massaging the data to make it suitable as the input to the model generation process. It is very important that we generate right model, and data massaging we need to do to get the data in a form and as suitable for the model to be generated, and that is why we need to transform the data first. Why we need to do? Wrong, inaccurate or inappropriate representation of data leads to wrong model creation. Think of the impact of a wrong model generated using the inaccurate or inappropriate data or not normalized data. Suppose we use that model in patient diagnosis or in patient treatment. If the model is wrong, then we can lead the doctors in the wrong direction by wrong diagnosis, which is very dangerous. And similarly, the treatment methodologies. Hence, we need to be doubly, triply sure that we have accurate and appropriate input, which is not wrong. And this is what is fed to our model generation process. Wrong decision lead to huge business and financial loss, because our model may be wrong, and business people, without knowing much on the model building process, may rely on that and land into huge business and financial loss. Wrong approach to the problems may waste plenty of time, money and resources. Hence, we need to ensure that as a first step, In the model building process, we think of what kind of data we have. Do we have the right data? Is the data accurate? Is the data appropriate? Is the data in a scale which is appropriate for the representation as the input to the model? Some of the data transformation methods, measurement units. It is necessary that we have appropriate measurement units when we input the data to the model building exercise. Removing duplicates. Duplicates can skew up the data and hence the model. Scaling, standardizing. We may have very high values in some of the features and very low values in other features, and this will favor the one with very high values in our model building exercise. Hence we need to standardize so that unnecessarily one of the features do not get weighed high. Sometimes our input need to be in a proper or a specific format. For example, we may require categorical variable or we may require numerical variable as input to some of our model building exercise. In that case, we may have to encode the character or string data. So we may do that using various encoding techniques. So various data types. Okay, our data may be in one data format. We may require them to be in a different format for enabling model creation or ensuring that the model analysis is done appropriately. Functional transformation. Yeah, we'll talk about that in detail in the next slides. Useful transformation utilities. As a part of this, we will also look at some of the very useful transformation utilities which are available already in the frameworks what we are using. Measurement units, how it is important. For example, we know that some of the drugs are prescribed in micrograms or mgs and some may be in mgs. Suppose if somebody misunderstands this and uses a milligram instead of microgram, there can be severe issues. So meters versus kilometers, inches versus feet, mile versus kilometer. So we need to be cognizant of the fact that what is the input we need to give, okay, whether the measurement unit is appropriate, and then ensure that our input is accurately transformed to the required input. Scaling and standardization. As I mentioned earlier, so we may have different features with the different values. For example, we may have a particular feature with say value exceeding million and another feature may be in decimals, 0.14 something. Now because one of the feature is at a very high value, so that can skew up the model building exercise and high weight may go in that favor, which may not be appropriate. Hence, we need to most of the time scale or standardize the values, and for that there are various facilities, utilities already available in the tool sets we use. Some of them are like min-max scaling, and so others are like you can use simply maximum value divided by the maximum value. You can have other standardization methods. We'll look at some of them. One of the popular method of standardization is Z-score standardization. This is scaling using arithmetic mean and standard deviation. New value A dash here is equal to A minus mean of A values divided by standard deviation of A values. And there are various utilities available as a part of pre-processing in sklearn, like normalize, standard scalar, etc., which we can use effectively. So we'll take a quiz now. So one of the questions which comes to the mind is, why do we need encoding? Audience, you can take the or give the vote on this. To convert text field to numeric fields, to enable input to the model generation, to reduce the overhead in the model generation process, to ease the understanding of the data by comparison, all of the above and none of the above. While you answer this, I will move over to the next slide. Encoding, this is very, very important again. As I mentioned earlier, some of the model generation algorithms may require specific inputs. Some may require only numeric inputs. So some may require categorical inputs. So we have to encode the label, okay, basically through a label, encode the data through a label. For example, logistic regression, we may not be able to give string input. We may have to label them as numeric thing, and this can be done by various methods like label encoding, one-hot encoding, hashing, tanh estimator, and it is very important to ensure that because we are using the encoding in the model building process, many times you have to ensure that these encoding are reversible or encodings are repeatable. That means when you use the test data, this encoding should work in the same way. Functional transformation. All the data may not be available in a normal form, and most of the analysis requires us to have the data in a normal distribution form. If it is not in normal distribution form, we may have to transform the data into a normal distribution, and for that we have various handy functions. Okay, we may transform the data into logarithmic function or box Cox transformation. So thus we can make the data as suitable input for the model building process, and some useful utilities in this regard for the functional transformation are sci-fi.stats.boxcox, numpy.log, numpy.exp, numpy.fft.fft. There are various utilities, umpteen number of utilities available for data transformation, and some of the important ones I have listed down here. It is not a all inclusive list. There are many more utilities which are not listed here but still available. sklearn pre-processing utilities. sklearn is one of the very good module which you can use for data transformation. sklearn.preprocessing has got various utilities. sklearn.preprocessing scale, preprocessing.standardscaler.fit, preprocessing.minmax scaler, preprocessing.maxapps scaler, preprocessing.quantile transformer.fit underscore transform, preprocessing.normalize, preprocessing.normalizer.fit, preprocessing.binarizer.fit, preprocessing.one-hot encoder, preprocessing.polynomial features, preprocessing.function transformer. In pandas we have got many more utilities. Some of them are pandas.series.str.normalize, pandas.io.json underscore normalize, pandas.datetimeIndex.normalize, etc. So many more utilities are available. You can look at these utilities and use them as appropriate. We have referred to various sources. So some of these are the sources we have referred to when we carried out the research work, and so we are also thankful to Stack Overflow for some of the very well answered issues. And now I will be handing over to Umesh for further discussion. Umesh, over to you.
Thank you so much, Umesh. With this, we would like to take the questions. Before that, I would like to highlight that if you have any further questions, kindly refer our book. We have extensively covered some of the techniques and some of the machine learning concepts with examples. So that book is available, and also we have given various talks in various forums. So you could also refer to those talks, and of course you can email us anytime, umesh@mytechnospeak.com or umesh@sigmau2analytics.com, and this is my phone number to contact if you have any questions. So with that, I would like to take questions. So I received a couple of questions. The first question is, I will read out this question. String match, we talked about similarity measure. Is it not a standard Python or Java library? Is it not a regular expression that we are using for very long time? So how is this considered as machine learning? So that's an excellent question. Well, we did not say string match itself is a machine learning. We use similarity measure, that is one of the concepts, in order to do further analysis to identify similar records. By itself, two-string matching itself, as you said, it's just a regular expression. You could use regular expression or any other techniques, and you can match as a Hamming distance or some other methods. You can do that. Absolutely correct. That is not machine learning. So we are using this to provide an input to further clustering analysis and, of course, the logistic regression for predictive analytics and other things. So absolutely correct. This itself may not, we cannot call that as a machine learning. So thank you very much for the question. The second question is, why is data transformation is an important step in machine learning, and how it can impact model? I would like Umesh and I to answer this question.
Yeah. So in brief, I have answered this in my discussion. Anyhow, let me take a few more details. Let me give few more details about this. Okay. For example, let us take we have a data source or a data set which has got, say, 590 records. Okay. And now some of these we see has very high value, and some of these have got very low value. Okay. This may be from say various sensors, so this data is coming. Now, so just because, okay, so one value is very high, it does not need to get higher weight, because each of these sensors are giving very equally important data. Hence, if we take the higher value coming from one of the sensors as the input to the model as it is, then it skews up the model. And how it skews up the model? Because that particular feature is given higher weight, and the one with very small decimal values, even though very important to the process, may not get the adequate weight. And if, say, in a set of, say, 590 features, what I am talking about, if 25 features have got very high values, and so remaining 565 equally important ones do not have very high values but very small values, but still important to the final outcome. So if you do not scale them, okay, using a scaler, appropriate scaler, then it creates a model which is highly in favor of higher values or highly weighed values which are coming from these 25 features, and it will skew up the model in their favor, and hence the model itself can lead us in a wrong direction by not giving us the right output. So that means it may not classify the output appropriately. Hence, we have to be very clear. We need to understand the business. We need to understand each feature and then see hey, whether feature-wise all are equal importance or all are of different importance, and our weight should be according to the importance and not according to the measure. And hence we need to be very, very careful, and we need to normalize the data appropriately. And some of the inputs, as I mentioned, need to be definitely to be there in the normal distribution format. Okay, if they are in non-normal distribution format, whatever you do and whatever results you get, okay, in your model building process may not lead to the appropriate outcomes, and hence may lead you in a wrong direction. Hence we need to be very clear in data normalization, and we have seen this as a problem across many of the data analysis projects. In the enthusiasm to create the models, people forget the very important step first of cleaning the data and then of normalizing the data. These two are very, very important. So very excellent question. Thanks for asking that question. Umesh, over to you.
Sure. Thank you so much, Umesh. With that, we would like to end this particular session. Thanks for all those who have attended. Kindly make sure to provide your feedback and ratings. That would encourage us for more sessions to conduct. So once again, thank you very much, and you have a wonderful day.
Thanks, everybody.